this is the set of images that are generated, and when the image, again the output features of layer 2 is applied to layer 3, this is some way that images are going to be detected, and this is the output resulted image. And when you give it to layer 4, what is going to happen? More, see, if you check from here, clarity from here to here had been increased, and here to here the more clarity of the image and more set of images, we are going to identify the images more accurately. When coming to layer 3 and layer 4, we are going to identify the images out some more accurately. But coming to layer 5, when compared to the previous layers, here identification of the characteristics as well as an images and everything is perfect here. The reason here is, when you move from layer to layer, initially the basic characteristics are obtained. When you move from layer to layer, the most complex characteristics are obtained. As the most complex characteristics are obtained, you are going to get an more accurate features, or more important features that are important for me, so that I can identify the things more accurately. And this is the first in basic structure of architecture of a CNN. Look at here, the input is taken and it is given to the convolution layers, and from the convolution layer it is given to the pooling layer, and from the pooling layer all the outputs from the pooling layer are fully connected here. And this concept indirectly will be called with the concept called as, by name concept called as, and flatten. And after flatten, they are, for example, the output, let us say we have 3 different classes, class 1, class 2 and class 3. So this is the output of class 1, this is the output of class 2, let us say this is the output of class 3. So we have 3 images, let us say cat, dog and human. So let us say class 1 belongs to cat, class 2 belongs to dog, class 3 belongs to human. So based upon the input, you will pass through these various layers, and if the input image is even, the output will be at the class 3. If the input image is at image is cat, the output will be at class 1. If input image is dog, the output will be at class 2. How it is going to happen? Basing on the convolution and pooling layers applied, and basing on the mechanism called as an training mechanism, we are going to identify the things that we are going to learn. So how the working of CNN will be there. So as I told you, an image can be of normally 2 types. One is of grayscale type and the other can be of RGB, that is called as an red, green and blue. It is also called as an color image. It is also called as an color image format. So each, as it is have 3 channels, look at each image is having width, each image is having height, each image is having width, and each image is having 3 color channels. This is an example of an image which is represented in the form of pixels, okay, in the form of a matrix, which is going to have width, height as well as in depth. So look at here, R, this is G, this is G and this is B. This is a representation, an RGB representation, okay. So look at here how, and this is the way how the image convolution, how the grayscale images and how the convolution layers works, because I told you that there is a convolution layer, and from the convolution layer you will go to the second layer. So we need to know, as I told you, that CNN is a combination of convolution layers as of now, followed by pooling layers, or many more can be added, but it is a combination of convolution layers as well as an pooling layers. So before applying convolution, we need to have a filter. Filter is nothing but to filter. You know the concept of filter. What is going to happen? The filter itself, it is going to reduce the features, or it is going to keep hold of the main features that are required. So an image will be applied to a filter. This is the sample filter, and once the filter is applied, and on the filter, basing on the filter image is applied on the filter, will get an output. If you take an example here, let us start from the beginning. So first, look at here. For this, let us say 1, 1, 1. I am writing it here 0, 1, 1, because here the image dimensions are what? 1, 0 is 1, 0, 1, 0, 1, 0, 1. So what we can write? If you take the first set, so 1 into apply it. So the image, the convolution means what? Convoluted, it is mapped. So the image features are taken 1, it is mapped onto the filter 1. So 1, and next pixel is what? 1, mapped onto what? 0. Next is what? 1, mapped onto what? 1. Okay, next is what? 0. Next this 0 mapped onto 0, and 1 mapped onto 1, plus 1 mapped onto 0, plus 0 mapped onto 1, plus 0 mapped onto 0, and plus 1 mapped onto 1. So this is 1, 0, 1, 1 and 1. So, this is 1 plus 0 plus 0 plus 1. This is, let us say, this is equal to 1 plus 0 plus 1 plus 0 plus 1 plus 0 plus 0 plus 0 plus 1, which is equal to what? 4. So, this is the thing we got. In the same way, now striding, because you have done for this part now. And now convolution should be strided. It should go for the second part. What is the second part? What is the second part? This will be the second part. I will explain that also. So, this will be because basing on this 3 by 3 matrix, so you need to select. So, basing upon the filter size, you need to select the things. As the filter size is 3 by 2, we are going to select a convolution size of 3 by 2. If the filter size is 2 by 2, we need to select the convolution size of 2 by 2. So, look at here 1. So, now how it becomes 1 1 0. See, because 1 into 1 plus 1 into 0 plus 1 into 1, 1 into 0 plus 0 into 1 plus, okay, 1 into 0 plus 1 into 1 plus 1 into 0 plus 0 into 1 plus 0 into 1 plus 1 into 0 plus 1 into 1. So, finally, it becomes 1, 1 and 1, remaining all zeros, that value is 3, this is 3. In the same way, it will be calculated for the entire set. Okay. This is the way how the convolution will be done. This is explained, and if you look at the diagram carefully, it tells you how the things are being done. And if you take RGB, as I told you, RGB is nothing but what? The image, if you say RGB, it is going to have how many channels? 3 channels, that's red channel, the green channel as well as an blue channel. So, if you take the red channel, so look at here, these are because an image which is consists of features called as and related to red color, which consists of features related to green color, which consists of features related to blue color. So, okay. So, now when you given an input, now the image will be classified into, in the image the entire set of features will be classified into 3 sets. One is related to R, other is related to G, and other is related to B. So, this set gives the features related to R, this set features the related gives to G, and this set features the related gives the related features related to B, and finally these 3 features should be combined, yes or no? Finally, the features related to red, green as well as in blue should be combined. So, if you look at here, the same how I calculated earlier will be taken. So, this is for red, the calculation, and this is for what? Green, and this is for what? Blue. So, first set will be taken. So, if you take the first set and first set features, because first dimension, first 3 by 3, first look at the diagram carefully, first 3 by 3 is being converted and moved. So, first set of features of R, the same will be taken, and next will be taken, next will be taken, and they will be combined. Next, again it will go to the second row, look at here, second row, third, slided, again slided, again it slided, 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 and the features of R, G and B are taken and they are combined. Slided, the features of R, G, B and are taken and they are combined. Slided, the features of R, G, B and taken are combined and slided. So, this is the way how the working of convolution will be done. So, you may get a doubt how the features will be reduced, because basing upon the filter size, the features will be reduced. So, the formula for how the working of convolution layer will be there, and what is the output of the convolution layer is given by W out is nothing but the output of the respective dimension. Here you have taken the W and W, these are called as dimensions of what it is called as the dimensions of height and width. Okay, there are the dimensions of height and width, and D is called as an depth. There is nothing but it can be either 1 or 3. So, okay, he is considering that the width and height and width are both are same. So, that is why I have written the formula W out is equal to W, there is nothing but the respective dimensions, minus F is nothing but the stride, F is nothing but the spatial number of kernels. Okay, kernels are nothing but the number of filters what you are going to use. Okay, and stride is nothing but, for example, if you look at this diagram, it is moving one column at a time. If you look at here the first, and it is moving one column at a time, that says that stride is 1. If you say stride is 2, 2 columns will be moved, means what? 1 2 3 4, next two columns will be taken, 1 2, instead of 1 2 it starts at 3 4. So, 1 2 3 4 and next 3, 4, 5, 6 in that way. If the stride is 3, 1, 2, 3, 4,